In Creo Parametric, you can calculate the degrees of freedom and redundancies for a mechanism. First though, let me show you how my mechanism works. If you take a look in the model tree, I have a whole bunch of components with a dot inside of a box. That means that those components have a mechanism connection instead of traditional constraints like coincident, normal, parallel, distance, and so forth. You can also see that I have a couple motors as features at the assembly level. Let's jump into mechanism mode. I will go to applications and then mechanism. And now in the graphics area, you can see a whole bunch of different symbols indicating the different connections that I have and also my motors. And so the way that this works, I have a couple of pistons in here. Each piston has a slider connection. So when the piston extends, it's going to end up pushing the arm, and the arm is going to rotate. And then you have the feet over on the ends of the arms, and they will also deploy when it hits the ground. So if I go to my analyses, I already have a kinematic analysis defined in here. I just have it run for 12 seconds with a frame rate of 25, and the motors on the left and the right running the whole time. Let's take a look at how it works. I will hit the run button. And again, you can see that the pistons extend, causing the arm to rotate, and eventually the feet will come into contact with the ground. Hey, have you ever seen like big giant backhoes or any of these different big scoops? They have these different feet on them that help stabilize the platform. So anyhow, I have run the mechanism. Let's click OK out of here. But let's say that I want to calculate the degrees of freedom and the redundancies. To do that, you can go to the measures command, and that will open up the measure results dialog box. Up at the top, you can choose whether you want to graph the measures versus time or one measure versus another measure. I'm not going to be using those in this case because I just want a report on the number of degrees of freedom and the number of redundancies. Redundancies occur when you have mechanism connections that restrain the same degrees of freedom. To create a brand new measure, I will click on the icon that looks like a new sheet. It's the standard new icon. And up at the top, we can give it a name. Let me call DOF, 4 degrees of freedom. And then we have a type drop-down list. You can see that we can create a whole bunch of different measures for things like position, velocity, acceleration. And we have some for dynamic analyses and impact. But I'm going to choose the category system. And then from system, we have a drop-down list for a variety of different properties. And you see right at the top, we have degrees of freedom and redundancies, and other ones for things like time and kinetic energy and momentum and mass. So let's leave degrees of freedom in there. You'll notice that there is no evaluation method. It's just going to calculate the number of degrees of freedom for the particular analysis. So let's click the OK button to create that measure. And now I will do another one using the same icon. Let's change the name, and I'm going to call this Redundancies. Let's see if I can spell correctly. And once again, we'll change the type from position to system. And now I'll change the property to redundancies. Again, we have no evaluation method. By the way, I could have hit apply the last time. It would have created the measure and then reset the dialog box so I could create another additional measure. But this is all I want to make for this particular model. Let's click the OK button. You can see my 2 different ones listed in here. Down at the bottom, we'll have the list of all result sets that we've already run. If I select the analysis definition result set, it tells me that I have 2 degrees of freedom and 6 redundancies. And at first that seems like, wait, that doesn't seem right because I've got whole bunch of pin connections. I've got a pin connection here, and then a couple over here. And then I've got the slider connection, and the same thing on the other side. Shouldn't I have 10 degrees of freedom? Well, then I also have these redundancies, which mean, again, we have certain degrees of freedom being restrained or controlled by the same connections. So now the question is, are redundancies bad? Well, really, they're only bad if you are performing a dynamic analysis. When you're doing a dynamic analysis and you're trying to calculate certain kinds of measures, especially ones that involve force, your calculations for those measures can be incorrect. So ideally, when you're doing a dynamic analysis, you don't want to have any redundancies. Here, though, I'm doing a kinematic analysis, so redundancies really don't matter to me. But let's say that you wanted to get rid of some of the redundancies. One way to do that is by changing some of your connections. Let's close out of here. I'm going to close out of mechanism mode for a moment. No, I'm not going to save the results. Let's regenerate to get back to the starting position. And so one way that you can eliminate some redundancies is by changing some of your connections. So for example, I've got this assembly over here. Let me edit definition. This is for the piston. If you take a look in the placement tab, I have a pin connection down at the bottom and a pin connection up at the top. Well, the way that these components are assembled in here, I really don't need a pin connection at both locations because a pin location down at the bottom will control translation for the connection up at the top. So I am really kind of over constrained with my second connection. Instead of having a pin connection up at the top, I could use the drop down list to change this to a cylinder connection, and that will free up 1 degree of freedom. Let's hit the check mark. And now I'm going to figure out, I think it's this subassembly over on the other side. Let's repeat that process. Let's edit definition. And then I will go to the second pin connection up at the top. Let's change this from a pin to a cylinder. Once again, a pin connection is 1 rotational degree of freedom. A cylinder connection is 1 rotational and 1 translational degree of freedom. But again, the translational degree of freedom for the cylinder connection is eliminated by the first pin connection. All right, let's hit the check mark once more, and let's go back over to mechanism mode, applications mechanism, and now I need to rerun the analysis. I will expand analyses in the mechanism tree, and then left click on the analysis I created, then hit the green flag, and it is running again. And now it has finished. Let's go back to the measures icon, and this time when I select the result set, we're still at 2 degrees of freedom and 4 redundancies. So we eliminated 2 of the redundancies by changing 1 of the pin connections to a cylinder connection. So that's one way that you can get rid of redundancies. There are some other methods like using weld connections. Welded comes up a few different times inside of Creo Parametric. I'm talking about specifically the kind of mechanism connection, not the kind of weld that I showed in a series of videos for welding parts together. But anyhow, there are methods for getting rid of them. If you have redundancies and you're not doing a dynamic analysis, it's really not that big of a deal. But then when I think about this particular mechanism, yeah, it kind of supposed to have redundancies because, again, just that one slider connection, moving that causes the various different pin connections to move because of how all these different components are assembled to one another. Let's go back and rerun the analysis. And if you take a look at this again, yeah, if you extend this piston, then it's going to cause these different components to rotate and move. So in this particular situation, hey, redundancies are what make this linkage work the way that it's supposed to work. But again, if you want to calculate the degrees of freedom and redundancies for your model, you create the different measures and then select the result set for which you want to calculate the values. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.